The mission for the Electronic Nanomaterials Group is to make and measure new nanoarchitectures that have interesting electronic behaviors and interesting electronic response. So what do I mean by that? Well, first of all, by nanoarchitectures, what we mean is the ability to control the nanoscale structural ordering of a material in order to control its bulk properties. And in particular, we're interested in its electronic properties. The advantage of nanomaterials is the ability to generate a property or a functional response that far exceeds what a conventional material might be able to do. So in essence, by controlling the nanoscale structure, we can influence the bulk properties, the bulk response of the material. The group is extremely interested in this concept of using nanoarchitectures for multifunctionality. So that is to say, have a single material that optimizes two different, maybe even conflicting properties. To give a concrete example, we have the ability to nanotexture a surface to control both its optical properties and its wettability properties. So for a solar cell, we want to reduce the amount of light that's wasted in reflections and instead have that light couple into the solar cell and be absorbed. Simultaneously, we want to tune the surface so that its wettability properties are what's called superhydrophobic. And what that means is that water will not stick to the surface and instead will just roll right off. And that makes surfaces inherently self-cleaning. One of the key challenges in optimizing electronic nanomaterials is the ability to really see the structures you're working with. And I mean both seeing them visually, so seeing their structure, but also understanding the electronic properties that are contained within those materials. And that's why within the group we have a collection of tools and capabilities to look at nanomaterials. So everything from electron microscopy in order to be able to image the nanomaterials, but also ultrafast optical spectroscopy methods. So these are methods to be able to look at the energetics of materials, the interactions between electrons and photons, to be able to understand how those materials are behaving. We can take the nanomaterial through its entire life cycle. That is to say, from conception to designing and fabricating that material, to measuring its properties, studying it at a fundamental level, and finally understanding its functional properties so that we can deliver it as an improved application.